Last type of spreader roll we're going to talk about is expanding surface type rolls. But there's three types of expanding surface rolls. First one is the slat expander, and basically slat expanders have mechanical slats that are made of aluminum, steel, or even the older ones are made of wood, and these slats are literally slide from the center of the roll face out towards each edge for 180 degrees of rotation, and then they move back in from the edges back in towards the center for the next 180 degrees rotation. Wrap angles around these rolls range between 90 to 180 degrees, but the more the wrap, the more the spreading. Theory of operation for this roll is you have these mechanical slats, again, underneath the web, and they are literally mechanically driven sideways from the center out towards each edge as the roll is rotating. And those sliding slats underneath the web will push wrinkles out towards each edge. And that's the theory of operation for the roll. Some advantages, they are an aggressive wrinkle remover. They do have a linear face, so tension does remain even across the roll face, so they won't stretch or distort any portion of your web. You'll see these rolls used a lot with woven and non-woven webs. While their surface is linear, it's not smooth, so they could scratch or deform some webs. And they can be a high maintenance item because you have a lot of moving mechanical parts. And the spreading is not adjustable with this roll. It's fixed, so you can't adjust how much those slats move as the roll rotates. Next, we have a polymer band expander. Basically, this roll is generally made with an aluminum face, and it has grooves cut longitudinally across the roll face, and you have polymer bands that are laid down inside those grooves, and the polymer band's surface is raised above the aluminum surface. These rolls, all expanding surface type rolls, have to be mounted as a dead shaft idler. So the slat expander, this roller, and the next roller I'm going to talk about, the center shaft is fixed and the roll face turns around that. Wrap angles range between 90 to 180 degrees, but the more the wrap, the more the spreading. Now, the theory of operation for this roll is you basically have a bunch of rubber bands all the way around the circumference. Each one of these is a separate rubber band. And then on each end of the rubber bands, there's a clamp collar that clamps and holds onto those rubber bands. We take those two collars and we angle them in on one side, and so they're angled away from on the other side. So if you measure one of these rolls in the field, this dimension from here across the roll face to here is literally shorter than the dimension from this point to this point. So the rubber bands have to stretch from the short side to the long side as the roll is rotating. And the stretching action of the rubber bands underneath the web pulls wrinkles out towards each edge. So the web enters on the short side, wraps around the roll, exits on the long side, and the rubber bands, the stretching action of those rubber bands pulls wrinkles out. They are an aggressive wrinkle remover. They have a linear face, so tension is constant across the web. It won't stretch or distort any portion of your web. The amount of spreading is adjustable with these rolls. All you have to do is adjust those end collars that are clamping onto the polymer bands. And you'll see these types of rolls used with all types of webs and all types of applications. Their surface, even though it is linear, it's not smooth. If you look at an end view of one of these rolls, you're going to have a raised surface wherever that polymer band is, and that could cause wrinkles in the cross machine direction. Polymer bands do wear out over time as the roll is rotating because they do stretch and contract every time the roll rotates, and so maintenance is required with this type of spreader. Last type of spreader is the expanding surface roll that has a continuous rubber sleeve. Again, they have to be incorporated as dead shaft idler, and there's a rubber sleeve that stretches as the roll rotates underneath the web, and that's what spreads your web. Wrap angles around these rolls generally range between 90 to 180 degrees, but the more the wrap, the more the spreading. Now, the construction of this roll is basically you have a center axle. On top of that center axle, you have what we call a disc support tube, and on top of the support tube, you have a series of rubber discs mounted all the way across the roll face. So there's underneath this rubber surface there's discs mounted all the way across this roll face. And then on top of the rubber disc there's a rubber sleeve. This is the adjustment screw to gain this angle. I will show you how the roll works in the next slide. And so when you screw down on this screw, you lift up on this flange, and that causes this collar to tilt. The theory of operation for this roll is basically when you again screw down on the screw, you lift up the flange, this whole collar tilts in this direction, and this collar tilts in this direction. So again, if you take a tape measure, if you were to measure one of these rolls in the field, the roll face is literally shorter on this side of the roll, and it's longer on this side. So this dimension is this dimension is a little longer than this dimension. Material enters on the short side of the roll, wraps around the roll, enters on the short side, wraps around the roll, exits on the long side. So as the roll is rotating, that rubber sleeve is literally stretching from the short dimension to the long dimension, and that's what pulls the wrinkles out. Advantages, they are a very aggressive wrinkle remover. You can adjust the amount of spreading from 0%, which would be no spreading action at all, to 100%, which would be maximum. And the spreading action can be made from each end of the roll while the machine is running, and it only takes standard tools. So if your operator sees more wrinkles on one side of the web than the other, you can adjust for that. Tension does remain evenly distributed across this roll's face because it does have a linear surface, so it won't stretch or distort any portion of your web. They're available with a lot of different sleeve compounds where high heats, chemicals, ozone, or adhesives are a concern. And they won't mark or scratch your web surface because they have a soft rubber sleeve for a surface. And you'll see these rolls used with all types of webs and all types of applications. Biggest disadvantages, web speeds are always a consideration because at high web speeds, the rubber sleeve can balloon away from those support discs. The rubber sleeve is not adhered to the support discs underneath, so centrifugal force can cause that sleeve to balloon away from the discs in high-speed applications, and then in that case you lose your spreading action. The rubber sleeve does degrade over time, and so maintenance is required. And spreading is not even in measured increments across this roll's face. You do get most of your spreading out towards the roll's edges and less as you measure toward the center. Now, the converting industry constantly evolves. New processes are developed. Thinner substrates are more common. Faster running speeds are always desired. And these and many other conditions can cause wrinkles. And wrinkles are one of the biggest profit eaters for converters. The spreader roll technology must strive to stay current with the converting industry. Spreader roll technology must do just that, spread all types of webs with little or no web distortion. Now, one of the things, this photo I always thought was very interesting because it does show how spreader rolls work. And this is what you want from your spreader rolls. You want performance. You can see this is an unwind roll, and I hope nobody in this audience has rolls that look this bad, but this roll is in pretty bad shape. But the real telling portion of this operation is where the web comes off the roll. You can see there's a bunch of wrinkles coming off directly off the unwind, and then the web goes around a couple of straight idlers, and you can see it's coming over this roller, and you can see wrinkles across this roller's face. So the idler rolls obviously don't take wrinkles out. But here's your spreader roll, and you can see the web is as smooth as glass going into the slitting head. And that's what you want. You want to be able to deliver whatever process this is. This happens to be a slitting head, but whatever your process is, it doesn't matter. You want to deliver your web wrinkle-free into your process. So you need that kind of performance out of your spreader rolls.